Hello and welcome to our webinar series on the industry application of generative AI and large language models. Today, we'll be looking at how manufacturing industries can harness the power of large language models and transform their marketing and service operations. I'm Ahmed, joined by Lohit, and will be your host for today. I'll quickly pass it over to Lohit to introduce himself. Hey, Lohit.
Thank you for the introduction, Ahmed Said. Hello, everyone. I'm Lohit Doradla. I work as a data scientist at Royal Cyber. I'm very much excited to take you through a live demo later in the webinar today. Back to you, Ahmed.
Excellent. Thanks, Lohit. We're thrilled that you're joining us today as we share our thoughts, insights, and best practices drawn from our experience in assisting organizations transform their business operations using data, analytics, and AI services. Just raise your hand if there is any technical issue, and feel free to pop your questions and comments in the Q&A section so that we can pick them up at the end. Well, that out of the way, let's dive straight into our content for today. Okay, so I will begin with a quick introduction to Roll Cyber, followed by creating a high-level backdrop of the type of manufacturing subvertical we're looking at, and then we'll delve into the solution mode, giving you a quick tour of the components of our solution for today. We'll then switch gears and jump into a live demo by Lohit, and then wrap up with answering any of your questions. Okay? All right. So a little bit about Roll Cyber. Roll Cyber is a global technology consulting and digital transformation company that specializes in services, software, and solutions. It's been operating in 10 countries around the globe for the last 20 plus years. Next, I'd like to spend a few moments commenting on the shift towards digital and AI within the manufacturing industry's primary activities. Now, the slide in front of you encapsulates the 4 key pillars of any manufacturing setup. So on the left, we have procurement and inventory. Now we can think of that as the resource maestro. This is where all things get lined up. All things that are required throughout the next stages all get lined up and procured over here. Next is production and development. So that can be thought of as a craftsman, molding raw material into valuable items. Then comes packaging and distribution, right? So that is the conductor, leading the final lap into the market. And last but not the least, marketing and support. So we can think of that as the ambassador. You know, they represent the product to the entire world. And as we can appreciate, each one of these stages are critical, right? Large language models such as Dolly can be the turbo boost they all could use, as we'll see that in the coming slides. Now we've taken a little bit of a deep dive into both the traditional manufacturing processes and followed by how AI has either already changed or can change some of these processes. And as we transition into discussing the role of Dolly in modern manufacturing, I think it is important to understand that the traditional methods, that have shaped the industry for decades. Procurement and inventory management can be thought of as the foundation. It's where the raw materials are sourced, managed, and prepared for production. And often, this process involves manual checks, order placements, and inventory tracking. When we take another deep dive into production and development, I'd like to think of that as the heart of manufacturing, right? A lot of hard work goes into this process, but at the same time, you know, traditional methods often involve a lot of manual labor and fixed schedules and quite rigid processes, which can slow things down at times. Packaging, pricing, and distribution. So once the product is made, it has to reach the customer, right? And this involves another layer of complexity, all the way from packaging design to pricing strategy and distribution channels. It's like planning a multi-city tour for a rock band, with each city having its own set of rules and preferences. That can get tricky very, very quickly, as you can appreciate. Marketing, sales, and support, right? So this is the final frontier. Traditional methods here involve blanket marketing strategies and reactive customer support, which we all can appreciate doesn't work well in the contemporary era. So let's see how the advent and advancements in AI have either revolutionized or can revolutionize some of these stages. So within the procurement and inventory management, just like we covered the traditional pillars, we can see that there's a transformative impact of AI here, and it's not just buzz. It is really the majority of the manufacturing. It is actually a reality that majority of manufacturing companies are either living upon every day or aspiring to incorporate in short-term future. So it's not science fiction. It is happening in current day. And what it does, it makes your procurement process very data-driven, right? So from the previous slide, if you remember the resource maestro, well, now it's got a crystal ball, and predictive analytics can foresee the supply chain disruptions and can adjust in real time, which is very valuable to any organization, let alone a manufacturing plant. The craftsman that we saw before has now gone digital, right? So we entered the era of smart production. Machine learning algorithms optimize production rates, quality, and they can even predict maintenance needs, which can cut costs significantly. Within the packaging and pricing, look, automated distribution, automated packaging, labeling and monitoring, advanced route optimization and dynamic scheduling. So it acts like a GPS system. The AI can help us optimize routes and automate the shipping process to reduce costs and time, which is again very valuable. And lastly, the conversational bots and personalized marketing, right? So our ambassador has evolved into a savvy conversationalist, right? Using chatbots powered by advanced analytics, we're not just broadcasting messages, but engaging into one-on-one dialogues with our customers. It's the personalized marketing, but with the added touch of real-time and tailored interactions. And as we take a deep dive into that, many manufacturing companies, particularly in sectors like lubricants and machinery and so on and so forth, traditionally haven't had direct sales or robust marketing as their strongest suit, right? But let's not overlook the latent value that lies dormant here, right? Such as between 10% to 30% revenue uplift and up to 30% cost optimizations, according to some of the studies that we've been conducting. Now, while AI has been helping us optimize for the first three pillars of manufacturing, as we just uncovered, applying it to marketing can unlock untapped potential. And imagine not just sending out generic messages, but having real-time, intelligent conversations with your customers or vendors. And this isn't just the future. This is what we'll be diving into for the rest of this presentation. So we are quite excited about this. And just to annotate, the business problem we'll be looking at today is centered around unearthing the upside potential for marketing, sales, and service streams for a vehicle slash machinery lubricant manufacturer, where our demo product mate aims to drive significant business results. Okay, so let's take a look at how we devised this solution. Now, here's a high-level architecture diagram that shows two main parts: bot press, which is going to be the front-end bot, and stack AI, which is where we can connect all of the other components to make this operational. Here's a couple of things to note here. A user queries the chatbot. The query is then sent to Stack AI, which provides us with the ability to run large language models like Dolly and connect to the proprietary data sets. Now, this schema also leverages vector databases, which can wrap themselves around the transformer model embeddings, and then render the output back to BotPress via an API endpoint. And then the user basically gets to see the response to their query or prompt. There's a couple of things here, so let's unpack that a little bit more. Stack AI is the major component of our stack over here, and Stack AI is a complete an end-to-end no-code AI studio where you can access a range of features through built-in native integrations across the entire pipeline that we just showed before. There are a lot of pre-built templates here to get you started, so feel free to check it out at stackai.com. Now, this is where we have hooked up Dolly, and as you go through the demo later, you will see that you'll also see a GPT 3.5 Turbo added to the mix to show that extra flexibility of Stack AI, where you can quite literally stack things on top of each other based on your use case, which is pretty fun. BotPress is a conversational chatbot, so it enables rapid creation of AI-powered chatbots through a user-friendly visual editor, just like Stack AI, making chatbot building accessible to both tech-savvy and non-technical audience, right? So some of the features, as demonstrated here, is that it has a real rich suite of integrations that can be pulled in. It is GPT enabled, and it can be deployed super fast. It's very easy to set up. And again, just like Stack AI, it has this sort of drag and drop visual flow editor. And it also provides you the ability to debug and do simulations, which really helps when you're creating the product. One additional aspect of our schema today is the vector or embedding databases. So we have chosen Chroma, which is an open source embedding database. And, vector databases are probably the most underrated tool in this arsenal, but they really make it easy to build large language model apps by making knowledge, facts, and skills pluggable for large language models. So it's really one of the key elements of building AI applications. As shown here, Chroma gives us the ability to store embeddings and their metadata. And we have demonstrated that through some examples where your documents could be product listings or user information gets added and converted into vector spaces. And then from those vector spaces, we, vector databases find that sort of the closest basically distance between what you've typed and the numeric distance for the next word or the next letter. Now, as shown here, the embeddings are the AI native way to represent any kind of data, as I was saying before, making them the perfect fit for working with all kinds of AI-powered tools and algorithms. They can represent text, they can represent images, and soon enough, audio and video as well. And there are many options for creating embeddings, whether locally using an installed library or by calling an API, which again makes it really flexible. And by default, Chroma uses the sentence transformers, such as the all-mini LM L6 V2 model, to create embeddings. It also includes providing a lightweight wrapper around other popular embedding providers, such as OpenAI, Cohere, Hugging Face, and soon Google Palm, which makes it really easy to use them in the application building. And you can set an embedding function when you create a Chroma collection, which will be used automatically, or you can call them directly as well. We've also done our testing, and it integrates really well with LangChain and Llama Index. If you wanted to cobble together, different things together as you're making your next AI application, so it is definitely a must to have. All right, now let's switch our attention to Dolly. To understand Dolly, we need to take a step back and understand three different ways to train a large language model. The first one is pre-training. That's the foundational layer that teaches a large language model basic language comprehension, such as summarization, generation of text, so on and so forth, using extensive data sets. Then comes the instruction fine-tuning stage. So this is essentially taking a generic large language model, such as GPT, Llama, or Falcon, and then sharpening it to follow specific instructions. That's where Dolly, Falcon Instruct, Text, DaVinci from OpenAI, for example, sits. And the last one is the reinforcement learning from human feedback. So this is, again, taking it to the next level and aligning models' output with human values and expectations. So for Dolly, which is created by Databricks, the first version costed them only $30. And it was creating using a data set developed by Stanford's Alpaca team, who initially used OpenAI to produce that specific data set. Now, Dolly or Databricks wanted to open source this model for commercial and academic uses, but they weren't able to because OpenAI's terms prohibits using its data to make competing commercial models. So given that it was based on OpenAI's data set, technically Databricks couldn't commercialize it. And there are some of the models, instruction following models like that, for example, Alpaca, Koala, etc., which all had the same issue. They weren't able to be commercialized. So Databricks then looked for another way to replicate what OpenAI had done when they created the Instruct GPT model that was trained on a dataset consisting of close to 13,000 demonstrations of instruction following behavior, right? So that's what OpenAI did. And for Databricks to take that journey, the first step was to find a pre-trained model. So they found a pretty robust open source large language model called Pythia, which is based on about 885 gigabytes data set called Pile that so spans across 22 different categories or representations of our world, different genres and different categories. So it's pretty wide data set and pretty sparse at the same time. And then Pythia contains two sets of 8 models of different sizes as shown on the screen. And all of the 8 models are trained on the exact same data and in the exact same order, which also have 154 different intermediate checkpoints per model, which, if you see on the screen, is the largest amount of checkpoints compared to any other instruction following large language model or pre-trained base models. The second step after finding that pre-trained model was to introduce instruction fine-tuning. So that's where Databricks had 15,000 quality handwritten question and answer pairs supplied by its own staff. And then the end result was Dolly 2.0, right? So an open source large language model that anyone can use, modify, or extend for any purpose, including commercial applications, without paying for any API access or sharing data with third parties, which is, again, pretty phenomenal. It's pretty cool. With Dolly version 2, as you can expect, data privacy is not an issue. You can fine-tune it without sending your confidential data to some third-party server. It really opens it up for a variety of use cases. And for Databricks, the way they came up with those 15,000 question and answer pairs was literally by crowdsourcing the data creation process to its staff, and then providing them with these 7 guiding principles, these 7 guidelines that you see on the screen, ranging from creating open and closed question and answer pairs, some Wikipedia-based tasks, to also encouraging creative writing and classification, and creating a strong emphasis on literally like creating a ban basically on the use of any generative AI content creation, just to ensure that the process is clean, right? We found that overall, Dolly is a great model for specific tasks, such as summarization, for example. Some positives we found, as listed here, is the features. So the model provides instruction following responses without irrelevant information or unnecessary language. The model perfectly resolves the pronoun references, for example, like they, them, across multiple questions, referring back to same entity, which again, some of the other models did not classify as well, or that well. Some negatives here. So again, is biased towards certain content due to being a public data set. It's weak at maths operations and code generation. And then you will see that in the demo that Loit is going to do, that he's also using GPT 3.5 Turbo on top of Dolly to generate a select statement from our Snowflake data warehouse, as an example. So that was one of the limitations we found. It is also less effective than the state-of-the-art models like GPT 3.5 Turbo, GPT-4, Anthropic, Claude, for example. And that's by design, because it's only supposed to be an instruction following model. And obviously it has limited functionality when it comes to dealing with dates, etc. So these are some of the limitations that we came across in our testing. And here we have it's a quick excerpt to demonstrate the schema of the model weights. So from the actual fine-tuning data set, which is available on Hugging Face. In this process, as demonstrated here, Databricks employees were invited to create prompt response pairs in each of the 8 or 7 categories that we've seen before. including all those 7 categories are actually part of the Instruct GPT initial paper. Each of these entries consist of 4 things. So in the instruction, the optional context, which is where they were allowed to use Wikipedia to basically get some context or reference, and that's the only place where they were allowed to use Wikipedia or any external referencing, I should say. Then the response, so the response to the instruction, and what category did it fall in? Again, so out of those 7 plus 1 categories, since 8 categories in total. And so this data set is available if anyone is interested in having a look. And this basically demonstrates that first Databricks had allowed them to only ask questions and then provide responses, but then later on they allowed answering other employees' questions as well, just to get that extra level of diversity as well. Alrighty then, time to see product mate in action. Here's a brief data overview before we jump into that. So we have downloaded data that is owned and produced by FUCHS Lubricants, which is world's largest independent manufacturer and supplier of lubricants. This case study is to demonstrate how we can apply our solution stack to data sets within a manufacturing industry context. In this data set, as demonstrated on the screen here, it has 8 columns consisting of product and related information. So we can ask a series of questions to our front-end product, and they'll respond based on the way we have created, which Lohit will walk us through. But let's take a quick look before I pass it over to Lohit. Okay, so we are on the front end right now. So this is the actual chatbot. Let's have a conversation. So let's say hi. Okay, so it responds back with some pre-canned questions. Let's just say we're here to get some product information. So what it does next is basically it's helping us to select the next prompt, right? So we're going to go further down into some of the brands. So I'd go ahead and select anti-carrot. Okay, let's see what it does. Okay, cool. And let's select, well, let's just select this product. Perfect. And I'm interested in product description. Okay, sounds like it's writing back. So it comes back with, with a very proper verbose description. If you read, we basically get a good gist of what the product does. Right on. Okay, so now it's saying, do you need any more information? And if you remember, we have this, in addition to Dolly, we're also using GPT 3.5, which performs better at code generation, right? As we discussed before. So here, it basically go in and write a select query in our Snowflake data warehouse. All right, so let's see what happens. Okay, perfect. Right on. So based on the prompt, it then came back to me with this response. And I think when I check the data set, it looks pretty cool. So that's pretty awesome. And I would now like to conclude our session. So I'll just say no. And no. And there we go. All right, so I'm going to hand it over to Lohit now. And Lohit's going to take us through a more detailed technical overview. Over to you, Lohit.
Thank you, Ahmed. I'll take it from here. So let's start the technical demo. In our demo, for modeling part, we have used the services of Stack AI, and for building the UI, we have used BotPress. So let's start with the model part first. So I'll walk you through the Stack AI part first. Now this is the homepage of Stack AI. Once you log in, you will end up coming here. Here, I'm basically going to show you two approaches or two scenarios. In the first approach, we are going to use an LLM called Databricks Dolly. We are only using a pre-trained model. Let's say if someone has a data set in an Excel or a CSV or a text format, and if they want to employ an open source model, build a flow and get the output, they can use this approach. I'll be showing it from the scratch. So once you come into this workspace, you'll have a blank page like this. You have different components available here. So depending upon the requirement, you just click on the component, drag and drop it, and then connect all the pieces, and then you will have an you can get the output. So for our use case, so we need an input node where the user will enter a query. We will also need an output node through which we will be able to check the output. Once we have this, let's click on data loaders. Basically, if your data is present on some DB or cloud or like Snowflake, MySQL, Postgres, you can connect with the credentials and then you can fetch your data from there as well. And in our case, we are using a document loader because we have a data set present in a CSV format. Now we have the input node, we have the document loader, which will hold our data set. The next step is to have a vector database. So we have basic and Chroma, and then we will use the Chroma. So this Chroma DB is basically used to store our data in a vector form, which is nothing but the numerical representation of our data. Now we have everything. We are just missing the one main component, that is the LLM that we want to use. Here you can see we have OpenAI, Anthropic, Replicate, Hugging Face. Under each of the model, under each of the component, we have different models. Under OpenAI, you'll have some models. Under Anthropic, you'll find some models. Again, under Hugging Face, you'll find some models. So for our use case, we are going to use Dolly, and Dolly is present under Replicate in Stack AI. So you can select Dolly here. So now you have all the components ready. Let's first enter the user query. Let's say if I want to know, let's say if I want to know like what are the advantages of anti-correct 6044. I put in the query here. Now let's connect the dots. Let's first understand the process. The first step is to actually, connect your input query to a vector DB. The reason is that the input query has to be converted into a vector form, and vector DB will help us to convert that. Once this is done, the next step is that since I've already uploaded my CSV file in the document loader, you can click here and then generally you can just select your CSV file. Next step is to connect your dataset or the document loader to your vector DB. So now even our dataset is also converted into a vector form. Now our vector DB is holding the user query and the dataset. It is storing them in a vector form. Next step is to connect your output of your vector DB to an LLM. So now our Dolly has information related to the user query and also the dataset in a vector form, and also the model needs the user query. You can connect it something like this. So now we have joined everything, almost everything, and the last step is to connect your model to the output node. Once we have done this, we need to add a prompt. So what is a prompt? Basically, you can give some instructions to your model on what you're looking at or what type of output do you want or what is the format of the output. So here I'm basically giving a very basic prompt to my model. I'm telling answer the following question that is coming in from input 0 node. This is the input 0 node. This is the context that is coming from the vector DB vector 0. Vector 0, give me a well formatted output. Now let's save it here. And then you can also check there are like different parameters that we have. There are different embeddings that you can use. I've used text embedding ADA002. And then there are also different parameters that you can play around with the model. I've almost put everything as default for our case. And I've just, increased the max length here. Now let's run it. Now you can see it is here. It has generated embeddings. Now we have the output. So we have the output now. So it says that the advantages of anti-gravity 6044 are excellent corrosion protection for ferrous and non-ferrous metals, indoor-outdoor protection, self-healing film, good removability. Since I already know the output is good, but it could be better. It could be in a better formatted way. Since we are only using a pre-trained model, we are not trained the model on our own data set. We can fine-tune it or train it on our data set, and then we can have better results. The reason for using Dolly here is that it is open source model. It is cost effective. It is also transparent in terms of that the dataset on which model Dolly is built is also openly available. It is also customizable. It means that you can, train it on your own dataset. Depending on the use case, you can give a proper tunes, structured prompts, uh, and then you can get good results. It is also deployable. You can also deploy it on cloud or on premise. And here, there's another step called evaluate. Let's say if you want to add a prompt, if the prompt is about 10-15 lines, and then you want to have an optimized prompt, you can add your prompt here, and then you can click on optimize. Eventually, it would give you a well formatted prompt. Once you have everything ready, you feel that your model is good enough, you can click on publish. Once you click on publish, it will update your model endpoints. You can see a successfully deployed. Everything is up to date. And then you can click on export here, click on API endpoint, and you can see the model API link here, API URL. You can use this link and then integrate it with different applications and then use the output of the model. So you can use this bunch of code. You can also test API by clicking here. So now let's get back. So this is about the first approach. Now let's move to the second approach. In the second approach, generally the data set is mostly present on either some cloud service or some kind of a database. And let's see how we can employ LLM for such a scenario where data is present on cloud or a database. In our use case, we are using a Snowflake connector. Our data, I've loaded my data on Snowflake. So in this approach, we are basically going to show you basically using two LLMs and trying to solve two problems. First one is to automate the SQL query generation process. The second one is to summarize and give a proper or accurate results for the user query. So let's first look at the different components that I have used, and then I will walk you through each step. So as as seen earlier, this is the input node where the user would input a query, and then I've loaded a document loader, a Chroma DB, and then we have our first LLM here. I'm using a OpenAI GPT 3.5 Turbo 16K model. And then I have this Snowflake. I've connected with my credentials where I have my data set present. So I have one output node here. The output from the first LLM would go here. And then I have another Chroma DB. This is this is the second LLM and the output for the second LLM. So let's understand what am I doing here. So in the first step, I've given a user query saying that what are the advantages of 5% mining Greece, summer, and winter. Now this user query, I've passed it to my Chroma DB and the embeddings are generated and saved here. And in the second step, I'm using a document loader. Basically, here I'm actually creating a metadata of my data set. So what do I mean by that? Metadata is nothing but it gives information about your data set. So here I've added the column description, like all the columns and its description, the column names of it, table name, and the data type of all the columns. So this information, I'm again passing it to my Chroma DB. Now, from Chroma DB, I'm passing this information to my first LLM. So I'm passing the user query and also the metadata of my data set. Now I'm telling my first LLM, the OpenAI model GPT 3.5 Turbo, to generate a SQL query based on the user query. So here I've also given a prompt saying that you are a helpful AI assistant to generate Snowflake queries. Make sure to generate relevant query. Do not try to invent anything. Use this context coming from vector 1 to generate Snowflake DB queries. Just return the SQL query. Do not try to invent anything other than SQL query. In the prompt, I also mentioned that answer the following question coming in from the user query. You have to generate the Snowflake query based on the question by using the context coming in from the Chroma DB. or just return the SQL query. Do not try to invent anything other than SQL query. Please provide a SQL query that retrieves specific data from a database. Ensure that the output contains only the SQL query itself without any additional information or context. Now, in this step, once the LLM runs, it is generating an SQL query. You can see that I've connected to output. It is selecting that select advantages from the table where product name is equal to 5% mining increase summer and winter. So this SQL query, which is generated by the first LLM, is sent to the Snowflake, and the Snowflake uh, intent and through this SQL query, we are able to fetch the data. So basically in the data set, we have 10 columns here and we have multiple rows, but based on the question, we only need some information. So that's how the SQL query is helping us, that you just want to select the advantageous column for a particular product. And this information is then passed to the second Chroma DB, and then this DB holds the dataset, relevant dataset information that is passed from Snowflake, and it also has the user query coming in here. Now, the user query and the information fetched from Snowflake is then passed to my Dolly model, which is the second LLM that I'm using. And then here I've mentioned that answer the following question in question coming in from the user query. This is the context, give me the output in points, and then it is finally giving me an output. Well, let's do one thing. I'll erase this output and then I'll just run it so that it will give you a better understanding of how the output would look like. Now let's save everything and then run it. Now you can see that it is here, everything is generated. Now you can see on the fly the SQL query was generated, and then this data is passed here, and then you can see that we have got the results on the fly. This is how good the SQL queries are generated, and the Dolly is able to summarize the output. So since I have already checked the results, the output generated, the advantages is properly set. But as mentioned, if we are able to train the Dolly model on our own data set, it would give you a better formatted and a better, more accurate results. So now the reason for using OpenAI model here instead of Dolly is that initially I've used two Dolly models, but the Dolly model was unable to generate the SQL query that accurately or that properly. That is the reason I had to move to OpenAI here, and in that query generation process, OpenAI was the winner. But then when trained on our own data set, Dolly would also give you very good results. So once everything is ready, you can click on publish and then click on export. In a similar way, you can then click on export and then you will have your endpoint ready. You can integrate your endpoint to the different applications. So these are the two scenarios which I've just showed you here. And I'm pretty much done with the Stack AI part, the model part. Now, the next step is to show you the UI part, the WordPress part, where I've designed my workflow, and then I've integrated the endpoint coming in from a Stack AI in my UI, and that's how I created my virtual assistant. So let's see on how did I create my UI on the WordPress side. So this is the WordPress homepage, and this is virtual AI. There's nothing but the workspace name that I've created. Let's click on edit. It will open a new window, and we can have a flow over there. So here is the flow. So basically, this is a kind of a drag and drop and less code UI kind of a thing where you can, connect to different components or different nodes. You can just drag and drop them. You can connect all the pieces, and then you can, design your UI or the design of the bot that you want to do. So let me zoom in a bit to have a better view of it. So there are some options available here. So you can see send messages like text, audio, and execute block where you can implement your code here. And then flow logic, let's say if you have some conditions, and then if it is yes, you want to do this. If it is no, you want to do this. And there's some AI task, AI generation as well. Capture information, that is like if you want to capture some user information, you have different options available here. So mostly I have used the text box here, execute code to execute my code here. and then single choice, and then raw input. So these are the few of the options that I've used in my flow. Let's try to understand like what am I doing here. So basically, you can do a right click here. I can click on standard node, so this will open a new node here, and then you can click on add card, and then you can select the option that whatever you want to select. Let's say I want a text box. I can select text here, and then you can see a text box is added here, and then you could enter a message here. So since we already have a flow built, let's understand the flow here. So the first step that I'm doing here, I have a welcome node here. So I've added a text box here. As I've showed you, this is a text box. So basically, as soon as the user enters a hello message, this is the information that I'm planning to send to the user. Hi, welcome to RC. I'm your virtual assistant. I'm here to answer any of your questions. Once this is done, I'm adding, I'm sending a question to the user, and I want to capture the information. For this, I've used an option called single choice, which is under capture information. The name itself says that you're trying to capture some information from the user. So here, I'm mentioning that what brought you here. I want to get product information. I want to buy a product. I want to talk to the representative. So the user can select, one option from here. And then this option would be saved in a variable called y here. So I've created a variable called y here. Basically, whatever information the user selects, that would be saved in this variable. And then we can use this variable in the later stages. Workflow dot is a default that WordPress provides, and y here is a variable which I have put in here. And also I'm trying to get a single choice question. This is where I've selected this option. There are also different options under this, but I've selected a single choice. Now, once a user selects, I want to get product information, it would route him to the next node. So the next node that I've created is the brand, and I've given a name called brand. So here I'm telling, fantastic, if you have come to the right place, I'm pleased to help you. And then again, I've added a single choice box here to capture the user information. I'm trying to ask him, which brand do you want? Like select a brand from the brand, select a brand from the different brands available. I've given like anti-corded, Renopom, Reniso, and so on. Now, once the user selects an option, it would be saved under a variable called which brand. Now, let's say the user has selected anti-correct. You can see there are different, flows going on, flows connecting to different nodes. Now, if you see anti-correct, this is connecting to another node. If you see Renoform, it is connected to this node. If you see Reniso, it is connected to another node. Now, let's say the user has selected anti-correct. Now, it would take us to the next node that we have here, and then I've named it as products underscore A, means products of anti-correct. So under anti-correct, we have multiple products. So here I've mentioned that select a product from the list. Now I'm giving different options to the user to select, and the user can select a product from the list. Now it could be that anti-correct 04 W2. Let's say the user has selected anti-correct 04 W2, and then it would route him to the next node here. And here I've named it as product info. So here I'm asking the user, what would you like to know about the product that you have selected? At the rate workflow.anticorrelate is nothing but anticorrelate product is a variable wherein we have different anticorrelate products, for example, like this. And then let's say the user has selected 04W2, and then we come to this node. Let's say the user wants to get the product description of it. He can select it. It would be saved under which feature variable. And then we are going to the next node where we are where the LLM would provide the response. Now here we would first have something like generate response, and then I've added an execute code block here. I've got this option from here, which is under execute. Now, what are we having under execute code block? So this is where we add our code. This is where we integrate the API URL or the endpoint that is coming in from Stack AI. If you see here, this is the input message or the query that is being passed to Stack AI. So you can, by seeing this, you can understand. So what I'm mentioning here is for workflow.brand. So this is which brand is a variable that I had created. The user has selected anti-correct. So for anti-correct, what are the which feature? So let's say the user has selected product information as a feature. So for anti-correct, what are the advantages of workflow.anti-correct products? Under anti-correct products, we had multiple products like anti-correct 04W2, anti-correct 0466 or 6044. So now what we can, so what is the output of this is for a brand called Anticorrid, what are the advantages or product description of Anticorrid 6044 product? Now, this question would be passed to the endpoint, and then we will be getting the output. And then this output will be saved in another variable called workflow.api response. This is how we can also add some custom code here, and then we can integrate it with some endpoints, and then we can get the output. Now in the next step, I'm sending the response to the user. That is, this is nothing but the response that I've got from my LLM, from the stack AI, and then this response would be showed to the user. In the next step, I'm again asking user a question. I'm asking user to enter a question on the fly, anything else that you would like to know, and then this information would be captured here, and then we again have code implemented. Since the user would ask the question on the fly, that question would be passed to this API URL, and then we would again get the response that would be saved in this API response variable. So this is how we would have our LLMs integrated, and then or the modal endpoints integrated. So once this is done, the next step that I'm doing is I'm asking the user, is there any other information you would like to inquire? So based on the option selected by the user, this information would be captured. If let's say if the user says no, it would take him to another node where I'm mentioning that thank you for visiting us. So this is how we generally build a basic flow. Initially, you have to think about the flow, and then you can implement these things. So let's test it here with a flow. Let's say I click on hello. So I have this message coming up, and then I have different options. Let's click on I want to get product information. Let's select the brand here. Let's say Anticorrid, and I have different products here. Let's say I want to select this product here. So what do I want to know? I want to know the application of this product, let's say. Yes, so we have got some output here. You can see the application of Anticorrid 04W2 is especially developed for use in solutions with solvents. So you've got the whole application of this product. And it says anything else that you would like to know? Yes. So let's say if the user wants to enter a query on the fly. Can you recommend me few products that have these features? So I'm asking for a recommendation of few products which have these features. So yes, we have some recommendations here. So based on the information that we have provided, it has given us some recommendations like Anticorrid DFO 6101. It has these advantages, and product name Anticorrid DFO 7301. It has these advantages. Now let's cross check it. So you can see I have given these advantages as my features, and then it is able to recommend me these products here. So yes, it is pretty good. Is there any other information you'd like to inquire about? No. So thank you for visiting us. So this is where all the variables are generally saved. And then also you can view the summary if you want to, if there are some errors, if you want to debug it, you can have all the information available here. And once everything is done, you can click on publish. That would save your latest version. And then you can also have this viewed on the browser. You can come here, you can click on pre-configured, and then you can click, you can copy this, and then you can always open a new window, and then you can paste it. This is how this is what we had seen at the beginning, the output. And also you can integrate with different options, like you can come here and click on browse and hub, and you can see here that you have different options to integrate it, like Microsoft Teams, Telegram, Messenger, etc. So I'm pretty much done. So thank you everyone for joining this webinar. Over to you, Ahmed.
Thank you, Lohit. It was so easy to follow along and create this on my own end as well. I think it would be super fun comparing whose bot gives us the better answers. But before we do that, let's also quickly reveal one of RollCyber's own product where you can see your data in action in seconds, just like we saw Lohit building this just a few seconds ago. So meet Connector. Um, and before we go into that, as part of our approach to help any company transform into an AI-ready company, we follow this 6-step process and have created an accelerator slash starter product called Connector that achieves all of this straight out of the box in a privacy compliant way. So this is where data becomes insight, right? Here we have pre-built all of the integrations, key large language models, and all the embeddings, supporting major data types and providing access to a private GTP environment if you're interested in keeping your data within your own walled gardens. So with today's webinar offer, where we're offering 3 hours worth of free consultation, feel free to connect with us to discuss more if you are interested in either exploring Connect product that I just demonstrated before, or just to hear more about some of our offers and some of our solutions. Okay. All right then. So this wraps up our session for today. We thank you for your time and look forward to connecting with you from here on. We'll now dive into the comments and questions. So let me open up the questions panel and then we'll go from there.